Hello, this is Elijah Peters. This is week 12 of Data Structures and Algorithms. This week is about priority queues, and we had three assignments to choose from. I chose the first one, which was the minimum priority queue assignment, and let's get into it. So first we have the import for the Java array list, and we use that to structure the queue between elements. So first we have we use the min heap data structure, and the heap is represented by an array list. The core data structure, which is an array list that presents the heap array, checks if the priority queue is empty and returns the size of the priority queue. The heap utility functions, and then there's the core operations that inserts a new item into the heap and maintains the min heap property by moving the item up the tree, which is the heapify up in the code. And then by adding the new item by the end of the list, we can restore the heap property, which is the heapify up, until its conditions are met. We then remove and return the minimum element from the heap. It restores the min heap property, moving the new root down the tree, which is heapify down, and the minimum element is the root because it's the first element. It's the least. And then we replace the root with the last element, and if we get down there, we only proceed with the heapify if the heap is not empty after removal. So it then corrects the min heap property, which is heapify up, by moving the element from the given index towards the root until that condition is satisfied. And then while not at the root, which is index greater than 0, the current node is smaller than its parent. We swap the current node with its parent and move up the tree. Then we get down to the correction. So this corrects the min heap down. So heapify down checks if the left child exists and if it's smaller than the current smallest, and checks if the right child exists. Down here, the if statement checks if the right child exists, and if it's smaller than the current smallest, it switches, and or it moves it up. No, moves it down. If the smallest moves it up, yeah. If the smallest element is not the current node, they swap and continue heapifying down. The demonstration and the helper method down here is just the data to insert, which is out of order, and then it repeatedly extracts the min element, so it acts like a sort. And if we run it, we see that it inserts those datas, the out of order data, and the initial heap, the representation of that, would be in order like that, from minimum to max, and then it extracts the minimum, and the remaining heap gets smaller and smaller until nothing is left. And that's our priority queue assignment. That is week 12, data structure and algorithms.